presenting my project called real-time feauture pipeline. This project process stream using user events in real time using Apache Flink, enriches the data, generates future values and metrics, and visualizes the results through a dashboard. Let me walk you through the complete folder structure and explain the purpose of each file. First, let's look at the files in the root directory .env.example file. This file contains sample environment variables required for configuring the project. Next, we can see the .gitignore file. This file specifies files and folders that should not be tracked by Git. Next, we can see the readme.md file. Here, this file provides the project overview, setup instructions, and usage details. Now we can see the analysis.md file. This document contains design decisions, architecture explanations, and performance analysis. Next, we can see the submission.json file. This file stores project submission details. Here we can see the batch comparison.py file. This script compares batch processing results with real-time pipeline outputs for validation. Next, we can see the docker compose.yml file. This file orchestrates all project services using Docker containers. Here, these are the root files in this real-time feauture pipeline folder. Now you can see the producer service files. Uh, um, in this producer folder, we have producer.py file. This script generates and publishes user events into the streaming pipeline. Next, we can see the requirements.txt file. It contains the Python dependencies required by the producer services. Now we can see the Docker file. It defines the container configuration for the producer. Okay. Next, we can see the Flink job folder. Uh, now moving to the Flink job folder, which contains the core streaming logic like Docker file. It creates the images for the Flink applications. Next, pom.xml file. It manages the Java dependencies and build configuration using Maven. Inside the source main Java pipeline package, future pipeline .java. It's the main entry point for the Flink streaming application and handles stream enrichment for joining user events with reference data. The model classes are user event.java, content metadata.java, enriched user event.java, future value.java, metric value.java. Processing and serialization. These are the models. Now you can see the processor and serialization. Here we have metrics process function.java. It performs real-time metric calculations. Next, Jackson deserialization schema.java. Here it converts incoming messages into Java objects. Next, future value serialization schema.java. It serialized future schema and metric value serialization schema.java. It serialized metric data. Now we can see the dashboard folder. Here we have app.py file. This is the backend application that serves dashboard data. Next, requirements.txt. It contains Python dependencies for the dashboard. The next one is Docker file. It defines the dashboard container configuration. Next, templates. Here, templates we have index.html file. This file provides the user interface for visualizing real-time metrics and future values. To summarize, this project includes event generation using the producer service, real-time processing with Apex Flink, future engineering and metric calculation, data enrichment through stream joins, dashboard visualization, and finally containerized deployment using Docker. Together, these components create a scalable and efficient real-time future pipeline. Thank you.